5-7 indirect measurement. I can measure indirectly by
Awesome, 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 awesome. Thank you, Natalie. Indirect measurement, then you see the definition for the vocab. We do have no cheat sheet there. We do not have a cheat sheet there because it is just the one word. We'll get down to some examples in a second. Really quick review. What does this symbol mean?
Similar.
Similar. So make sure you remember that this symbol right here means similar. Down here on number 2, then, we actually have an example of indirect measurement where we have a shape. Triangle ABC is similar to triangle DEF. I've given you the side lengths for ABC. I have given you one of the side lengths for DEF. By the way, just for fun, as a review, do you guys know that side length? Or could you calculate that side length? Using what? Say that again. It has nothing to do with the lesson, but remember, if you know both legs, actually if you know 2 of the 3 sides, doesn't matter if you know the hypotenuse and one of the legs, you should be able to solve using Pythagorean theorem, right? But anyways, that's not the point here today. The point is we want to solve for our missing side here, which is x. And the way we did that was we set up a proportion. We said that since we know these figures are similar, they're the exact same angle measurements, they're just a different size. We know that 3 over 4, so 3 over 4 is going to be equal to, are these sides corresponding?
Yes.
So do we have the 3 corresponding with the 9?
Yeah.
And is 4 and x corresponding?
Mm-hmm.
So should they correspond with each other in your proportion?
Yeah.
So 3/4 equals 9x, and then we use what to solve for x? What do we start with? What's the cross products, right? So we use cross products, got 3x equals 36, solve for x, which was 12 units. Now, the second way that you need to know how to do is scale factor. We need to figure out how to go from 4 to x. Are we getting bigger or smaller?
Bigger.
Huh? Bigger. Well, first of all, the shape looks bigger, and if you looked at the corresponding sides in which you have the actual numbers, is 9 bigger than 3? Yes. So we actually have to use those to figure out the scale factor. How do you go from a 3 to a 9, you guys? Divide 9 by 3 or multiply 3 by 3, right?
Yeah.
So your scale factor is 3, and if you know that, we could take this 4, multiply it by 3 to get x, which is still going to be 12 units. I'm not going to spend a lot of time on this. Line up your labels for number 2 is our example. Number 3 is more of a real lifer. There's a building, there's a tree. We showed you the height of the building. We showed you the height of the tree as a variable. We showed the shadow is 8 feet from the building. The shadow from the tree is 3 feet. And you should be able to solve for the height of the tree, not only using proportions like you see right there, but also by calculating scale factor. And I think it was Jake that told us the scale factor is 375 thousandths. Brandon, please don't rock it out in the middle of math class. Okay? Any questions?